Hello and welcome to another video session of geekvale. We're going to talk about the area of a shape in a rectangular coordinate system. Now the prior information that you must need for this lecture is the distance formula and the rectangular coordinate system. Also you can check out that lecture on the perimeter of a shape in a rectangular coordinate system. With that being done, we're going to continue. Okay, I've picked these questions from this book called The Big Ideas Mathematics, Common Core Geometry. Okay, if you look at question 21, 22 and 23, they are about the area of the triangle, area of rectangle, and the area of the triangle ABF again. Number 24 is about the area of the quadrilateral ABCD. If we look at the quadrilateral ABCD, it would be something like that. Okay, something like that. This one, not that certainly. Let me take that away. Okay, this quadrilateral is actually covering the triangle, the rectangle, and this triangle as well, right? So when we calculate the area of this quadrilateral, it will be the calculation of this triangle, this rectangle, and this triangle as well. When these three areas added up, we get the area of that quadrilateral, right? So if we solve question 24, that will be like solving question 21, 22 and 23 together. Okay, so we can say that the area of quadrilateral ABCD will be equals to the area of triangle ABF plus the area of rectangle BCEF plus area of triangle CDE. Now all I need is these three things, and then I can plug them in here to get the area of my quadrilateral ABCD. So the first thing first, I need the formula for the area of the triangle. The area of triangle is equals to half times base times height. That's the formula for the area of the triangle. Okay, so we can say triangle ABF will be equals to half times base times height, correct? Now what is the base of the triangle ABF? That's this triangle, by the way. This is triangle ABF. So the base of that triangle is actually AF. Base is AF, distance AF, and height is what? Height is that distance FB. So the new formula will look something like that. The area of the triangle ABF will be equals to half times the distance AF times the distance FB. Right? Half times base times height. So all we need is that distance A, F and FB, and to calculate those distances I need these three coordinates. The coordinate these three points, sorry, point A, point B and point F. So let's write them down. Point A is minus 5, 4. Point B is 0, 3, and point C is minus 2, 1. Point B is 0, 3, and point F is minus 2, 1. Okay, just to make sure, recheck that again. Okay, I have these 3 points now, so I can calculate the distance AF using the distance formula x2 minus x1 whole square plus y2 minus y1 whole square. So for AF, it will be x2, this one will be serving as x2, and that will be serving as x1. So I'll get minus 2 minus 5 whole square plus y2 minus y1 whole square. y2 will be 1 and y1 will be 4. 1 minus 4 whole square. AF will be minus 2 plus 5 whole square plus 3 whole square. What's minus 2 plus 5? That will be 3 square plus 3 square is 9. That will be 9 plus 9, and that will be square root of 18. Okay, that's the distance AF. The distance AF is square root of 18. The second thing that we need is the distance FB. So let's get rid of that first of all. Raise it out. Okay, we need to calculate the distance FB. The distance FB will be equal to x2 minus x1 whole square again. So in this case, B will be serving, 0 will be serving as x2, 0 minus minus 2 whole square. You can use it the other way around. You can do minus 2 minus 0, still stays the same because you're taking the square. And y2 minus y1 will be 3 take away 1 plus 3 take away 1 whole square. You'll get 0 plus 2 plus 2 square. You'll get, sorry, that is square. 2 square plus 4 equals to 4 plus 4 equals to square root of 8 equals to 2 square root of 2. So we calculated FB, which is 2 square root of 2. Now all we need to do is multiply them together, and then we will have the area of this triangle ABF. Got rid of that. Okay, the area of the triangle ABF will be half times square root of 18 times 2 square root of 2 will be equals to square root of 18 times square root of 2 will be equals to square root of 18 times 2, because if you have two individual square roots being multiplied with each other, you can multiply them in one square root. So you'll get square root of 36, which is 6. 6 what? 6 meters square, centimeters squared? No. 6 square units, or 6 units square, because you have not been given any unit here in this case. So the area of the triangle ABF is 6. The similar way we're going to calculate the area of the triangle CDE. Okay, let's get rid of that first of all. Quickly get rid of that. Okay, for the triangle CDE, we can highlight it. This is the triangle CDE. Again, we're going to use the base and the height formula, half times base times height. So what is the base of the triangle CDE? Its base is ED. ED is serving as the base. And the height is what? DC. So we calculate the distance ED, which is x2 minus x1, 4 minus 2 whole square, plus y2 minus y1, minus 5 minus minus 3, minus 5 minus minus 3 whole square. So the distance ED will be from there, it will be 2 square plus minus 5 plus 3 whole square. The distance ED further, I can write it down as 2 square will be 4, minus 5 plus 3 will be minus 2 square, will be 4 plus 4 will be square root of 8, which is also 2 square root of 2. So we calculated that distance ED, which turns out to be 2 square root of 2. Okay. The second thing that we need is the distance DC. The distance DC will be, again using the distance formula, we can do x2 take away x1, which will be in this case 4 take away 4 whole square, 4 take away 4 whole square, plus y2 minus y1 minus 1 minus minus 5, minus 1 minus minus 5 whole square will be 0 square plus minus 1 plus 4, is it? Minus 1 plus 5, sorry. Minus 1 plus 5 whole square, and we will get 0 square will be 0 plus 4 square. Square and under root can cancel out with each other. 4 units for that. Now we can easily calculate the area of the triangle CDE as well from here. So I'm going to write it down now. The triangle CDE will be half times distance ED times distance DC, and we will have half times 2 square root of 2 times 4, which will be 4 square root of 2 units square, or square units you can call it. So we calculated that area of the triangle CDE, which turns out to be 4 square root of 2. The last thing that we need is the area of the rectangle BCEF. So we can get rid of that, all of that. So the area of the rectangle, I'm gonna just use the rectangle shape for simplicity. It's not a mathematical concept. You can just I'm gonna just use that for writing it down because it's gonna take a lot of time and too much space. So rectangle BCEF will be base times height. So what is serving as the base of that rectangle? The base will be the distance FE, and the height is the distance EC. Okay, EC is serving as the height. Okay, now with that being done, we can calculate FE and EC. So FE distance will be again x2 minus x1 whole square, which will be minus 2 minus minus 2, or you can do 2 minus minus 2. Both ways you'll get the same answer, minus 2 whole square plus y2 minus y1, which will be 1 minus minus 3. 1 minus minus 3 whole square. Distance FE. Absolute, you can check the lecture on absolute as well, why we use these two lines. The distance formula uses absolute, and the answer to that will always be positive. So you will get minus 4 square plus 1 plus 3 from here will be 4 square. 16 plus 16, square root of 32. Okay, we got square root of 32 from here. Square root of 32, which is the base of this rectangle, or the distance FE. Square root of 32. Let's get rid of that now. The second thing that we need is the height, which is the distance EC. We have already calculated that, but we're going to calculate that again for this bit. Okay, EC distance again. x2 minus x1 will be 4 take away 2 whole square plus y2 minus y1 minus 1 minus minus 3 whole square. Okay, 4 take away 2 will be 2 square plus these two minus multiply, minus minus plus, minus 1 plus 3 will be plus 2, 2 square. You'll get 4 plus 4, you'll get square root of 8, you'll get 2 square root of 2. We got 2 square root of 2. Okay, with that being done, we can take that away, and we have the area of the rectangle BCEF will be square root of 32 times 2 square root of 2. As I mentioned earlier, when two under roots multiply, you can multiply them inside one under root. So you'll get 2 square root of 32 times 2. You'll get 2 square root of 64. You'll get 2, 8. You'll get 16 from there. So the area, this rectangle turns out to be 16. Now we have calculated all these areas. So now to calculate the area of the quadrilateral, all we need to do is add them up. So let's get rid of that. So the area of the quadrilateral ABCD will be equals to the area of the triangle ABF, which is 6, plus the area of the rectangle 16, plus the area of the triangle CDE, which is 4 square root of 2. So the final answer will be 16 plus 6 will be 22, right? Plus 4 square root of 2 square units. So you can add this up, and that will be some answer in like a decimal form. And I don't have a calculator right now, so I cannot calculate it. You can check it by yourself. Make sure to subscribe to my channel and share it with your friends. You can follow us on Facebook, and if you have any confusion, you can post that in the comment section. You can always visit our website if you need tutoring for any subject or further details as well. Thank you.